Assalamualaikum and hi to everyone. This is a Physic group project. My name is Muhammad Azhar bin Baharum. My group member is Amar bin Muhammad Noor, Muhammad Anis bin Abdul Wahab, Izu Akmal bin Abdul Ghaffar, and Muhammad Nurbani bin Abdullah. The situation is a group of 5 students were asked to undergo a study tour in the construction area. There are several things that can be attributed to physics. Title is Free Falling and the Newton's Law of Motion concept. Next. Introduction. A free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in state of free fall. There are two important motion characteristics that are true of free-falling objects. Free-falling objects do not encounter air resistance, or free-falling objects on Earth accelerate downward at a rate of 9.8 meter second squared. In Newtonian physics, freefall is defined as the motion of an object where gravity is the only force acting upon it. Next, freefall. An object only experiencing gravitational force, assuming in vacuum condition. The important note: freefall do not mean that the object is falling down only. Objects thrown upward and downward and those released from rest are all the examples of freefall.
Assalamualaikum. My name is Amar bin Muhammad Noor. My matric number is TB19104. I will continue the group assignments lah. Free falling. During each second of fall, the speed of an object changes by 9.8 meters per second. The change in speed is due to gravity, hence the acceleration is called acceleration due to gravity. Acceleration of the object is g equal 9.8 millisecond. Velocity at the time, distance traveled by the object. Next, free falling graph. There is two graph show the free falling and this is time, and for the upstate is position. State the slow flash with a large downward velocity, and for this graph show it shows start from the rest v equal to 0, and then it go to the slope negative 9.8 meter per second, and the other slide will continue for the next student. Thank you.
Here we go to the example 1, which is: suppose a free fall ride at an amusement park starts at rest and is in free fall. What is the velocity of the ride after 2.3 seconds? We will be using the kinematic equations. Final velocity equal to initial velocity plus AT. Since free fall ride start at rest, so the initial velocity is equal to 0. And A equal to negative 9.8 meter per second square and T equal to 2.3 seconds. And final answer is negative 23 meter per second, which is free fall ride will be going downward. How far do people on the ride fall during 2.3 seconds time period? So this is the equation for the displacement, and this is the final equation for displacement, which is 1 over 2 at square. Next, 1 over 2 times negative 9.8 meter per second square and times 2.3 seconds square. And final answer is negative 26 meter, which is the people will fall 26 meter. Let me go to the situations. The construction workers accidentally drops the brick from a high scaffold at the construction site. What is the velocity of the brake after 4 seconds? So we will be using the same equation as before, which is the initial velocity is equal to 0 and A equal to negative 9.8 meter per second square and T equal to 4 seconds. And the final answer is negative 39 meter per seconds, which is the brake will be going downward. How far does the brake fall during this time? So this is the equation for the displacement. Just put the value into the equations, which is 0 plus 1 over 2 times negative 9.8 meter per second square times 4 seconds. And the final answer is negative 78 meter. So the brick will fall 78 meter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Saya TB20005. Okay, saya akan present tentang Newton Law of Motion. Newton Law of Motion states for every action, there is an equal and opposite reaction. The image show that, for example, the baseball forces the bat to the left, which is an action. The bat forces the ball to the right, which is a reaction. Okay, for our situation, for our group project, the group of 5 students needs to go to the top of the building. Assume the total of students' weight is 400 kg and using an elevator that briefly accelerates at 0.20 gram downward. Okay, during the acceleration, what is their weight and normal forces? Weight, mass times gravity, 400 kg their mass, and times 9.8 for their gravity, so equal to 3920 Newton. That is weight, and for normal forces, Fn minus Fg equal to negative Ma. Fn equal to negative 400 times 0.2 times 9.8 plus 3920. So Fn equal to 3136 Newton. That is normal force. Okay, Newton law of motion. If the lift moving up, R equal to mg plus ma for acceleration. R equal to mg if the constant velocity. R equal to mg minus ma if negative a deceleration. For the lift moving down, R equal to mg minus ma for acceleration. R equal to mg, same as moving up. For constant velocity, R equal to mg plus ma for negative a deceleration. Okay, that's all.
Hello, thank you my friend. My name is Muhammad Ani bin Abdul Wahab, TB 19112. I want to continue my slide. Gravitational and normal force. First, the force of gravity can be written as Fg equal mg. The direction of the force is downward. As example, the driver exerts an upward force followed as contact force, and it is referred as Fn. So, Fn and Fg must be equal in magnitude but opposite direction. Next, conclusion. Free fall is any motion of a body where its weight is the only force acting upon in the context of general relativity, where gravitation is reduced to a space-time curvature. A body in free fall as no force acting on it and it moves along a geodesic. Second, Newton's law of show how objects behave when they are moving standardly and when force acts upon them. As our example, so that lift how long does it take whether go up or down based on the force and weight in the lift. Thank you.